Welcome to Kenton Teaches. Enjoy the video.
You start by writing the map as x equals a x plus t. Once written, isolate the invariant point p satisfying p equals a p plus t, because the invariant point is where input equals output. Compute I minus a immediately and justify doing so. You will solve I minus a p equals t. Make sure to check the determinant of I minus a. If it's non-zero, you have a unique solution and you can proceed to solve the linear system directly. Now you solve I minus a p equals t by standard linear algebra. If the matrix is small, compute the inverse or use Gaussian elimination. For larger matrices, use LU or QR to be stable. Once you obtain p, substitute it back into the map to confirm p equals a p plus t. This check catches sign errors or arithmetic slips. If your software returns a near-zero residual, accept p. If not, refine numeric precision or rerun decomposition. Finally, handle degenerate cases and validate. If det I minus a equals 0, you cannot get a unique p. Instead, find invariant subspace or parametrize infinite solutions, or apply Moore-Penrose pseudo-inverse to get a least squares invariant. Once done, make sure to validate by direct substitution and compute the residual norm. A tiny norm confirms success. Troubleshooting tip: if residuals are large, increase numeric precision or recondition the system by
Thanks for watching. Please subscribe if this video was helpful.